I want to thank everybody for coming tonight. My name is Dakota Moore. I'm with the Kentucky Horticulture Council. And before we get started and I introduce our speaker tonight, I want to drop a link in the chat to a webinar we had last week with Jackson Rollett from No-Till Growers. This was a great webinar. He talked about a lot of different things involved with no-till growing and just sustainable ag in general. And then we also want to advertise some upcoming field days that our friends at the Organic Association of Kentucky are putting on. So they've got one coming up in April at Pavel's Garden. It's April 13th, and that's in Crestwood, Kentucky. That one is a 4-acre diversified market farm. They do covered growing as well as field growing. And then there's one coming up in May, on May 9th. This is at Fowl Family Riverside Farm in Sulphur, Kentucky. And this one is, they are a livestock farm. So if you want to attend those field days, that link I just dropped, you can register for those. The one on April 13th may be full, but I'm sure the one in May is still open. And so today our speaker is Dr. Shawn Lucas. He is Assistant Professor of Organic Agriculture at Kentucky State University, and he does research on best management practices and soil quality and organic production systems. So I'll turn it over to you, Shawn, and you should be able to share your screen.
Thank you for inviting me, Dakota, and having me be part of this series. And thank you, Dakota and Cindy, for all the work that you all are doing with the Hort Council. Certainly appreciate the way that you all are helping Kentucky growers. And I'm excited really to talk about soil health. I've been studying soil health since around 1999 when we were calling it soil quality. You know, it's something that people think about when they need to think about it, when they realize they have a problem. But more recently, we've been thinking about it in terms of the impacts of agriculture on our atmosphere. And I just heard today on, I guess it was NPR, I was driving in, and they made the statement that agriculture is responsible for about 11% of the greenhouse gas emissions in the United States. And that's actually up 2% from what I'm teaching my students in class, which I've been saying 9 to 10% over the last year or two. And I guess they've upgraded it to 11%. So, you know, we have some work to do. I think a lot of us are concerned about climate change. I've been studying soil carbon dynamics for 20 some years now, and it's kind of both sad to see it finally becoming as important to everyone as it is, but it's also exciting to see that yes, people are starting to understand that we need to think about how we're managing our soil in terms of soil health and in terms of soil carbon, which in my opinion as a soil scientist is the most important thing that we can manage to promote soil health. And so we'll get into that here in this presentation. Just to kick things off, I am the organic ag guy at Kentucky State. I'm assistant professor of organic agriculture, and I've done a lot of work with industrial hemp as well. But my training is actually as a soil scientist, and I have focused on soil carbon and soil health, like I said, for about 20 years. Since I do focus on organic, I like to throw a few tidbits about organic into presentations. The picture here on this slide is the Rodale Institute in Kutztown, Pennsylvania, and they have been looking at soil management in organic systems since the 1940s. And so I grew up in Pennsylvania. I think it's kind of a pretty picture. You can see a lot of the research plots there. We don't have quite as many research plots at on the part of the farm at Kentucky State that I manage, but we are doing a lot of good work in looking at best management practices and how we can build our soil health and get the productivity out of our systems that we want. Let me see if I can make this move forward without any glitches. There we go. So, I'm at Kentucky State University. We're an 1890 land grant. We're a historically Black college, and when it comes to soil health, people have understood soil health and have talked about soil health for a long time. Going back to George Washington Carver, he doesn't often get the credit that he deserves in discussions about soil health, particularly when we talk about the history of soil health. He was thinking about and teaching about soil health back in the late 1800s, before it became, what it is in modern times. He wasn't necessarily calling it soil health, but the things that he was thinking about and the things that he was promoting are exactly the kinds of things that we do think about in soil health. So he was, an extension agent at Tuskegee Institute. And before he was at Tuskegee, he was at Iowa State as a student. And he was taking a mobile lab around and teaching people about sustainable farming practices. He was promoting crop rotations, looking at ways to reduce soil erosion, soil depletion from growing the same crop over and over again in the same spot. And he recommended, no, we shouldn't be growing the same crops in the same spot every year. We should be rotating nitrogen fixing crops like peanuts in with soybeans and cowpeas. And of course, in Alabama, they're also growing cotton and sweet potatoes. And so he had them mixed into a very diversified rotation. And I was down at Auburn University a few years ago for a cover crops conference, and they are still using aspects of the rotations that George Washington Carver devised in their cotton growing systems in Alabama. So it's pretty neat to see the contributions that he made. This is Carver's mobile agricultural lab, where he was, taking classes to small scale minority farmers in Alabama. So early extension, right? Carver spent time at Iowa State as a student, and he befriended Henry A. Wallace, who was the son of a pretty famous agriculture professor at Iowa State, named Henry A. Wallace. So Henry A. Wallace II was the son, and the professor was Henry Wallace I. The son, the second, not only did he befriend George Washington Carver, but eventually became U.S. Secretary of Agriculture and Vice President of the United States under FDR. But Wallace and Carver used to talk about soil health, and Wallace's ideas of soil health, he actually first coined the term soil health in a thesis he wrote, at least as far as we could figure out, looking at a literature review. Historically speaking, he was the first person to really throw out this term soil health. But he focused a lot on physical and chemical properties of soil, your nutrient profile, and how well your soil conducts water, but didn't really get into some of the biological components that we think about in modern soil contexts. And so, as we moved forward, more people started recognizing the importance of soil biology. But in the big picture, I want you also to think about what was really happening in modern agriculture, right? So we had people talking about soil health, people like Carver, people like Henry A. Wallace, and certainly people like Rodale and some of the more famous folks that came out of Europe, right? Like Sir Albert Howard and Rudolf Steiner. Some of these folks were promoting the ideas of soil health, but at the same time, we were becoming a highly industrialized agricultural system that was relying more and more on mechanization and on chemical use in agriculture. And so, it sounds like something the organic guy would say. Look, we've benefited a lot from mechanization and from chemistry in agriculture. We've figured out how to feed a global population that recently hit 8 billion people. And so I'm not here to say that all agriculture is, bad if it's not organic. But it is interesting to look at. We had people talk about soil health and talking about the things that we're starting to think about coming back to, right? People were talking about this stuff at the same time our agricultural system was really going in a different direction in terms of, the types of inputs we were using and we still do use, and relying heavily on fossil fuel utilizing machinery, right? So as this thinking about soil health was evolving in the 30s, from the 30s to the 80s, we were really ramping industrialization in agriculture, but there were still people thinking about soil health. There was a USDA publication that came out in 1936 called Soil Health and National Wealth. They come right out and say plants and animals, bacteria, molds, lichens, moss, algae, worms, insects, all have played and continue to play their part in mixing and investing the soil with nutrients, which make it the matrix for plant growth. So they recognize the importance of biology. Wallace didn't really get into that, but people started to recognize that. And people started talking about the relationship between soil health and human health, drawing out those connections where if you're managing your soil appropriately, your crops may be, a healthier crop, which also translates to healthier in your ecosystems. More importantly, healthy crops, healthy ecosystems, and those are all linked to human health. Cox was a scientist that was doing some research in the 70s, and they came up with this idea. Not came up with the idea, they got evidence. They had evidence that suggested that there was a relationship between diverse healthy soils and plant disease suppression, and some of that into if you have a healthy soil, you have a more robust microbial community in that soil, and those organisms can help outcompete some of the bad actors in terms of microorganisms in a soil system. And again, then moving forward into the 80s, this idea of soil health and societal health, and it ties into ecosystem health. And we all need to remember that as human beings, it's easy to kind of get disconnected as we all sit in our offices with concrete walls and our computers in front of us, but we're all part of an ecosystem. And if the ecosystem around us is deteriorating, the things that we depend on and take for granted from that ecosystem aren't going to be as readily available. And so we can have societal issues and societal problems connected with the health of our soils. Here's a societal issue that was related to poor soil management, right? Going back now to the 30s, Franklin Delano Roosevelt, he recognized after watching the devastation that occurred with the Dust Bowl incident. You had, if you look at this picture on the bottom left on this slide, you could see that's a dust cloud somewhere out in the southwest, and those clouds rolled across the southwest. That was the topsoil being stripped away by wind, and that is your best soil being carried up into a cloud and carried away from your farm, right? And those Dust Bowl incidents were so bad that the buildings in Washington, D.C., like the Washington Monument and the Lincoln Memorial, those are white marble buildings. They had a brown tinge to them because of the dust that moved across the plains eastward with the winds. If we don't keep our soil covered and don't manage our soils well, we can end up with situations like we see in the bottom right picture, where you have pretty problematic erosion starting to take place. And you can see the rills forming across the landscape. And as you have erosion and deterioration of soil organic matter, you can have formation of soil crusts take place, which is what we see in the top right picture. And if you're a plant trying to get through that crust, what happens is the soil gets wet, and then it dries out. And as it dries out, since it doesn't have a lot of organic matter and the topsoil has been stripped away, what you're left with is this sort of structureless mishmash of soil particles that just leads into this crust formation. And it's hard for plants to get up through that. So it's really hard to get your crops established if you run into that kind of situation. So Roosevelt recognized this, and one of his more famous quotes is, "A nation that destroys its soils destroys itself." And so we need to think about how to preserve our soils. Coming out of Roosevelt's administration was the Soil Conservation Service, and they are now what we know as the NRCS. NRCS has done a great job over the last several decades of really getting soil health out there into the public realm, getting people to think about soil health. And again, this is kind of, to a lot of us, it's a new concept, but it's an old concept. When I started graduate school in the 1990s at University of Maryland, we weren't calling it soil health. We were calling it soil quality. And this is, this was this idea that was defined by the Soil Science Society of America and the Agronomy Society of America, or American Society for Agronomy, rather, which I'm a member of both organizations. They're professional organizations for, soil geeks and crop geeks. And so they spent a lot of time trying to define this idea of soil quality. And they said, well, it's the ability of a soil to carry out certain ecosystem functions. In other words, if you have a soil, some soils may be highly suited to building houses in. That's an ecosystem function, right? That's something that humans use the ecosystem for. Humans use soils for. Certain soils are going to be good quality for building houses in. Certain soils are going to be good for growing crops in. Some soils are great for making, pottery out of. They don't all necessarily overlap. Sometimes they do. Often the best soils for building houses, unfortunately, tend to be the ones that are good for growing crops in too. And we see that with urban expansion. I live in Lexington. Places that used to be farms here outside of Lexington are now, Walmart parking lots. And so I'm thinking specifically of the University of Kentucky South Farm. It used to be a much bigger farm, and that is now part of what used to be the farm. It used to all be Waveland at one point, and part of what used to be the farm is now, under pavement at Walmart. So it was a good quality soil for building. It was a good quality agricultural soil. Those are Maury silt loams over there, and some of the best soils in Kentucky for growing crops. Also pretty good for building on. All right, so soil quality, soil. Sometimes these terms you'll hear interchangeably. As this idea has evolved, soil health has really picked up on the notion that biology is critical. We think of our own health, human health, and that's, we're biological organisms, and we can be affected by other biological organisms, right? So soil health really does focus on, biology to do the nutrient cycling that our crops depend on. It takes biology to build that healthy soil structure that allows air movement and water flow in the soil, and allows root penetration in the soils. So, biology has recently been recognized as a key to this soil health concept. This is something we can test, we can assess it, and we can manage it, but it's not as simple as, dropping a dipstick into a glass. Like pH, you can take a piece of paper that's a litmus paper or a pH paper and drop it into a solution, or drop it into your soil with some water, and it'll tell you, oh well, it's a pH is 6.1. Maybe I want to add some lime, right? At some point. Soil health assessment is not that easy. You have to really understand the system, and you have to monitor. It takes different approaches to monitor it. So I'll touch on some of that. But, my work at Kentucky State, and I think what a lot of people are really interested in terms of soil health, is how can we best manage our systems to promote soil health and again, grow the productive crops that we need while maintaining that soil resource for future generations, right? And I don't know how many people on the call here want to pass the farm on to their kids, but if you are thinking about that, you want to make sure you're passing on a good resource and not a depleted resource, I'm sure. So, soil health again, now that much like soil quality, people have tried to put definitions to this. And so NRCS calls soil health the continued capacity of a soil to function as a vital living ecosystem that sustains plants, animals, and humans. Other organizations have subtly different but similar definitions. So the UN is a little more focused on ecosystem function. They talk about the ability of soil to sustain productivity, diversity, and environmental services of terrestrial ecosystems. Environmental services is kind of a jargony term, and you'll hear people like me, scientists, talk about this. If you do a deep dive on some of this stuff, you might see in ecosystem services or environmental services. It's just a fancy way of saying the benefits that we get from the environment, or the benefits that people get from the ecosystem, right? So if we're trying to sustain those services, we're trying to maintain the benefits that the soil provides for us. So what are some of those ecosystem services? Again, these are the benefits that people get from an ecosystem. And as I mentioned earlier, it's easy to forget, but we're all part of an ecosystem, right? And we share the air, and we share the water, and the soil provides food for us. So these are all part of the ecosystem that we exist in, and the benefits that we get from that are ecosystem services. Let's take a look at some of the ecosystem services that soil plays a role in. Starting from the bottom right, we don't really think about soil as governing air movement, but if you lived in the soil, if you were a microorganism or an earthworm or a plant root, that soil controls the air that you can get, and the structure of that soil really determines how well that air is provided, and it also plays a role in how well water is held in the soil. And so the air movement and the water are inherently linked. If we have a rainy day, the spaces in between the particles in the soil are going to be filled with water. And as the soil dries out, they're filled with air. And there's, a nice balance in between air saturation and water saturation. And it provides everything your roots need, especially if you have a well-structured soil that can support that balance. We may not think of soil as a habitat, although there are plenty of cultures that build their homes out of soil. And if you have a brick home, you may not think about it, but your home is built out of soil. So soil is a habitat in some cases for people. But, when we're talking about soil health, soil is a habitat for the organisms and the earthworms and the very small arthropods and insects that do all that hard work of cycling nutrients and creating that healthy soil ecosystem that helps us grow healthier crops. In the middle there, you see decomposition. That's a picture of a cow patty that I almost stepped in on a farm a few years back. But imagine if we didn't have decomposition taking place, right? Cow patties everywhere. We'd be walking on them every day, right? No, we wouldn't even be here, because without decomposition, we wouldn't have nutrient cycling, and the plants wouldn't get the nutrients that they need. And without the plants, we wouldn't be here. So decomposition is critical in this natural cycle of life and death and circulating nutrients. In our plants, in our agricultural systems, and in our natural systems, they really rely on that decomposition to get the nutrients they need. And then in the bottom left, we've got water supply and purification. We may not think about soil as a filter. I studied at University of Maryland, and one of the first things I learned from a soil scientist named Del Fanning was that dirt is what you track in on your shoes, and soil is the stuff that's out in the field. We often kind of conflate the two, soil and dirt, right? So you don't necessarily think of soil as a filter, But when you look at it on a watershed scale, all that water that moves through a watershed has filtered through soil somewhere. And because of the chemistry of soil, it does act as a filter, cleaning out a lot of things that we probably don't want in our water. It's debatable whether we want some of those modern things, chemicals and whatnot in our soils either. But they're a little more available if we're talking about drinking water sources. So the soil does act as a pre-filter as our water moves through the watershed and into the lakes and rivers that we might use as reservoirs or intakes for your local water supply. If everything's working right, you got a healthy soil, you've got habitat for microorganisms, you got air movement, water holding capacity, decomposition taking place, water infiltration and purification. And maybe your soil is a pretty good soil for plant growth as well. And so these are, again, ecosystem services, benefits that we get from the soil that we often take for granted. And they're all inherently linked to the health of the soil. And if we can manage one thing to promote the health of a soil, it's soil organic matter. This is something that I think a lot of farmers are increasingly aware of at this point, that soil organic matter builds soil structure, ties into air movement, water movement, it ties into the biological activity in the soil and how well those microorganisms are able to break down organic substances and decompose those substances and provide nutrients to our crops. And over time, we can either build soil organic matter or we can cause soil organic matter to deteriorate based on how we are managing our agricultural system. When we look at what soil organic matter is related to, it's related to all the important things that go into having a healthy crop. If we're looking at it from agriculture, from an agricultural perspective, again, there's biological aspects, decomposition, nutrient cycling, storing carbon. I didn't mention that soil organic matter is about 58% carbon. But as we are moving forward into a future where carbon is going to be something that is going to increasingly be part of the conversation that we have to have in terms of mitigating climate change, we want to keep the carbon in the soil where it does good things, and we want to minimize excess emissions of carbon into the atmosphere where it can become problematic. And so who controls the carbon in the soil? Well, our management influences it, but the microorganisms, which are also influenced by our management, really control how well that carbon stays put in the soil. So biology is a big part of it. Physics, the structure of your soil. It determines how well your water moves into and out of your soil. It determines how well air flows, how well water soaks into the soil, infiltration. That's all part of the physical properties of the soil. That's linked to organic matter, and it's also linked to biology. And then the chemistry, right? CEC is cation exchange capacity, and that plays a role in how well a soil can behave as a filter in an ecosystem. It also plays a role in nutrient holding capacity, and also affects, how much lime you have to add. If you're going to add lime to your soil, you get a soil test that says I've got to add lime. That cation exchange can determine about how much you have to, or it will influence how much you have to add. So it's good to understand, but it's related to soil organic matter. It's also related to clay, but soil organic matter influences cation exchange capacity. All right, so we looked at a slide like this a second ago. What ecosystem services does soil affect? This one's a little different. It says, what ecosystem services does organic matter affect? And it looks pretty similar, right? Air movement, habitat, decomposition, plant growth, water supply and purification, all those things we talked about before, directly related to organic matter. And so with that in mind, and with it in mind that soil organic matter is the key component of a soil that we can manage to promote soil health, I like to take a little deeper dive into soil organic matter. There's a scientist by the name of Fred Magdoff He wrote a book that if you want to learn more about this in layman's terms, Dr. Magdoff and Harold Van Ness. Magdoff was at University of Vermont. Van Ness was at Cornell. They got together and wrote a book called Building Soils for Better Crops. Really good resource. They wrote it, I think first edition was 1992. They've updated it several times. I think you can actually download it for free from Sayre's website. And just a great resource. Magdoff kind of in that book and beyond that book, but he lays out this idea that there are 3 kinds of soil organic matter in that book, Building Soils for Better Crops. And Dr. Magdoff says that 3 kinds of organic matter are the living, the dead, and the very dead. And so when we're thinking about, well, what is living soil organic matter? It's things like your plant roots, small animals, insects, arachnids. So things like mites are arachnids, small spiders, pseudoscorpions, which are kind of little creatures that look like scorpions without tails. Nematodes, which are microscopic worms, and then of course microorganisms, right? Of course microorganisms are alive. We don't see them without the aid of a microscope usually. If you look at this picture that I put on here, you can actually see some fungi that are growing throughout the soil. And I shouldn't imply that this is not magnified. This is magnified with a microscope. It's probably one of my favorite pictures in all of soil science. If you look at the arrow on top, it's pointing to the very tip of a plant root. And the lower arrow is pointing to a fungus that is growing through the soil. That's what we refer to as a fungal mycelia, growing through the soil. But if you look real close back up to the root, you can actually see little wisps of spiderwebby stuff growing off of that plant root. And again, this is the tip of a root. It's the smallest, most finest part of the plant root as it moves, penetrates down through the soil. It's a pretty small, maybe a little bigger than the diameter of a hair. But there are places in the soil that root cannot access. It's too big to get in between certain particles and certain spaces. But I call your attention to those little wisps on that root because those are fungi. Those are mycorrhizal fungi. They live in the root, they live on the root, and they grow out from the root, and they have a symbiotic relationship with that root. So this is soil microbiology interacting with that root. The plant benefits because that fungus that grows in and on the root could get into spaces where they can't get. And so that fungus has added water and nutrients that the plant cannot access. And as we think about that, we might think, well, what does the fungus get from the plant? Well, the soil is a pretty competitive environment. And so there are microorganisms battling it out in the soil for habitat and for living space. The fungus gets a nice safe place to live. It lives in the root, it lives on the root, plus it gets to freeload a little bit because what's that plant doing? It's photosynthesizing and creating sugar from carbon dioxide and sunlight, and it sends a lot of those sugars down to the roots, and the fungi gets a little bit of a free meal from the plant, or it trades its meal for nutrients, right? So if you're thinking about living organic matter, plant roots, insects, arachnids, nematodes, microorganisms, all of those are important components of living organic matter. The dead, what is the dead organic matter? Well, these are like recently deposited organic materials, stuff that's fairly easily decomposed. This is the stuff the microorganisms break down and cycle nutrients out of, and those nutrients then become available to the plants that are growing in that soil. This is the stuff that, as food for microorganisms, it promotes microbial activity, which in turn promote a healthier soil structure. When microbes break down organic matter, they release gluey substances into the soil, and that gluey stuff helps hold sand, silt, and clay particles together, and into sort of aggregates, clumpy structures, and those clumpy structures promote air movement and water holding capacity. And so you can start to think about how all these things are tied together. And of course, decomposition is tied into nutrient release. And then you have the very dead. I don't know if anybody composts here, but as you turn your compost pile, your lettuce leaves and your spinach and your coffee grounds and all that stuff, it breaks down over time. And when you get that nice finished compost out, the reason it's a nice finished compost is because it's highly decomposed, it's highly digested by microorganisms. And this is kind of this same idea of the very dead organic matter in the soil. It's stuff that has been highly decomposed, it's been chewed up and spat back out by the microorganisms. They can't do much more with it, so it's fairly stable and it sticks around for a long time. This is the stuff that has a lot of chemical properties, organic matter. It's related to that cation exchange capacity that is related to soil nutrient holding. And again, it's kind of fluffy and spongy, so this also contributes to water holding capacity and air movement and soil structure. And so I think, that living dead and very dead framework is a good way to think about organic matter. So as I mentioned earlier, we can assess soil health, but you can't just drop a dipstick into a glass and get a reading. You got to look at the big picture. You can measure things like crop yield, you can measure water quality, but all of those things are single points that don't mean much when you don't look at them in the context of everything else, because again, this is an ecosystem that we're talking about. So we have to look at how that soil supports different functions and how we are sustaining those functions for the future. So when we think about, what can we manage and what can we test, certain things are inherent in a soil, and certain things are things that we can change. So inherent soil health is related to the proper soil itself. Sandy soils, they drain faster than a clayey soil. That may be good in a wet waterlogged year, but that's not going to necessarily be good in a drier year. Right, you might want some of that clay content. A deeper soil has more room for roots than shallow soils, right? These are things though that we can't really change. We can't economically add sand to a soil or clay to a soil to change the soil texture. We can't economically truck a bunch of topsoil and to change our soil depth. So yes, those things are related to a soil's health and a soil's productivity. Those aren't we can really manage. The things that we can manage are all related to soil organic matter. The amount of soil organic matter in the soil structure, soil biology, water holding capacity, nutrient holding capacity. And so depending on how we're taking care of our soils, we can change those qualities. Here's another kind of look at that, right? Things that change quickly, you don't want to measure those for soil health. Today it's dry, tomorrow it can rain. So our plants might be wilting today and tomorrow they'll be fine. That's, that looks like our plant health has changed, but that's not really a change in soil health. pH, right? We can add lime and change the pH in relatively short order, a matter of a couple days to weeks with lime. In modern agricultural systems, you can, excuse me, I think we've got a kitchen emergency. My wife is cooking something up for the kids for dinner, and that's our fire extinguisher, smoke alarm. I'm sorry. Never know what you're going to get around here. All right, so you can change mineral fertilizers, right? Nitrogen, phosphorus, potassium. In our modern agricultural systems, we can add fertilizer and bring that nitrogen level up to where we want it, potassium and phosphorus. None of those are really related to the overall long-term health of a soil. So we want to think about things that change over a couple of growing seasons, not immediately. And we talked a little bit about like soil depth, topography, climate, texture, the material that your soil is forming in. Here in Kentucky, in central Kentucky where I am, it's a lot of limestone materials. So that's the parent material of the soil. You can't really change that. What we want to think of soil health as far as measuring it are soil properties that change over a couple growing seasons. Aggregation, soil structure, right? The microbial content of the soil, and different soil carbon related parameters. So I'll get in a little bit more about what labile carbon is, and SOM is just an abbreviation for soil organic matter. So, you take a soil test and you send that to your soil testing lab, whether it's UK or Waters Ag or wherever you're sending it, you can get back a soil organic matter reading. Labile carbon is a subset of soil organic matter, and it is a more microbially accessible subset of soil organic matter. And so we have found over the last couple of decades that this labile component of soil organic matter, if we go back three-tiered pool with the living, the dead, and the very dead, that labile pool is really the living and the recently dead. And again, this is the stuff that is related to, biological health of a system, cycling, all those things that we've talked about in terms of soil health. That labile component of the soil organic matter is really related to that stuff. And so people have been increasingly finding ways to measure that labile component. If you're a producer, right, and you're interested in this, there are some soil health testing options out there. And I'm not promoting or saying bad things or good things about Waters. I'm just relaying what they have here. As a state employee, I'm not really supposed to endorse anybody, but I can tell you what Waters has. They've got some commercial options for testing soil health. And if you send them a sample, they'll do like what they call their basic 4 soil test, which is complete nutrient analysis, phosphorus, potassium, calcium, magnesium, your micronutrients. They'll tell you about the salt content. They'll tell you about the aluminum content, which aluminum you don't want in your soils. If you can avoid it, aluminum can become toxic to plants at higher concentrations. They'll tell you about available nitrogen. They do what's called the Solvita CO2 burst test, which is a test to try to get at the microbiological activity in the soil. The Solvita SLAN, which is available nitrogen, biologically available nitrogen. They'll do a test called active carbon, which relates to that labile carbon that I was talking about in the previous slide. And it's actually the test that's a picture of me out at KSU's farm. We've got a portable system that we could take out in the field and do active carbon right out in the field. And so I was demonstrating that on the farm at KSU. It's a pretty simple test. Involves shaking some soil up with a chemical, potassium permanganate, and based on the color change in the solution, it can give you an idea of how much labile carbon you have in your soils. Waters will give you an aggregate total organic matter. It's definitely not a bad suite of tests, but these tests, if you're going from a commercial lab, they can get expensive if you're sending lots of samples in. And unfortunately, though, our universities, they don't usually have soil health testing options. University of Kentucky, to my knowledge, does not. You could send a sample to regulatory services and they'll give you like something similar to the basic 4 soil test that water has, plus they have pH, cation exchange capacity. They'll tell you what your soil texture is, and you get your organic matter and total nitrogen, and it's a lot less expensive, but they don't offer some of these more soil health tailored tests. A couple universities have tried setting up soil health testing labs. Ohio State had one for a couple years, but they've kind of put a pause on it because the person that was running that lab took another job at a different university. I think Oregon State has a soil health testing lab and Cornell does, but they're few and far between. And so if you're a producer interested in this, you got to kind of do your own research and figure out, what tests you might want to do if you're trying to test it using some of these modern tests. Let's be real. Farmers know what's up. Farmers know what they're doing, especially farmers that have been at it for a while. And I think, most farmers probably know what goes into a healthy soil. Does it crumble into aggregates, or is it kind of chunky and break apart into hard clods? That's an indication of soil structure. How it smells, it sounds funny, but that earthy smell that you get from a good healthy soil, or to me, if you want to get a real example of what I'm talking about by the earthy smell, you go out in the woods in the fall after the leaves have dropped, and you take the layer of leaves off and you pick up that really dark, fluffy organic material that's right under the leaves, which is really last year's leaves that have just decomposed for a year. And they got that earthy smell that's actually produced by microorganisms. And so that's an indication of a healthy soil. How does a soil? I look at the picture in the lower left, and I don't know. Let's pause for a minute. What do we got? 7:24. We're supposed to be done at 7:30. I better not pause. But I can look at these two soils, and I know which one is the healthier one just by looking. And if I'm in person, I usually ask the audience, hey, which one of these looks healthier? And people say, oh, the one on the right looks healthier. Why? Well, because it's darker and you can see it's got better structure and it's got more roots moving through it, right? So I worked University of Maryland for a couple of years. I was working with a scientist named Ray Weil, and another graduate student that was there when I was there was Joel Groover. And Groover and Weil, they did a study on this, and they found that farmers could tell what a healthy soil was, and the soils that were healthy had higher levels of different things that related to soil carbon and soil organic matter. It wasn't so much the pH of the soil, it wasn't so much the calcium or magnesium ratio or phosphorus or potassium levels. When farmers were identifying soils that they rated as higher quality, healthier soils, they always had these higher levels of organic matter related substances. So farmers have a sense of what a good healthy soil looks like. I've kind of talked about some of this slide. What I want to just highlight here is again the management component. What are we doing? What have we been doing in modern agriculture in a lot of systems that has caused a depletion of soil organic matter? Tillage, erosion, monoculture cropping systems where we're not really using diversified crop rotations. These are things that over decades will cause our soils to decline in soil organic matter and in turn in soil health. And again, as we manage it, you can have a couple different scenarios. Soil wants to find the equilibrium, and so it can stabilize at a certain level. But if the management changes for the worse, say you've increased the amount of tillage, you can go from a stable situation to a deteriorating situation, or maybe that stabilized situation was good, but it wasn't the best possible scenario. And so if you're adding things like cover crops and manure and compost to your soil, you could actually see an improvement in soil health. And again, this is all related to organic matter. I touched on atmospheric reasons to want to manage carbon. Soil organic matter is 58% carbon. The more carbon we keep in our soil for soil health, the better that ecosystem functions, and the less that we are emitting into the atmosphere. So how do we what are some strategies for thinking about soil health? Well, keeping the soil covered is one. This is a cover crop in the picture here. It's got rye, hairy vetch, and red clover. It's a mixed cover crop. You're going to get nitrogen input from the clover and the vetch. You're going to get a lot of carbon input from the rye. But you're also doing the right thing in terms of keeping the soil covered and preventing erosion. So cover crops, keeping the soil alive. Mother Nature doesn't ever leave a bare soil, right? And so we are trying to mimic Mother Nature here and keeping the soil growing. And growing different things, not a corn soybean rotation necessarily, but a more diversified rotation. And maybe you're thinking 3, 4, 5 years out. I see a lot of people that do this in organic ag, where we do grow 3, 4, 5 years of different rotations. We avoid the monoculture where you're growing the same crop in the same place every time. Um, Diversified crop residues. I don't like to eat the same meal every day. Neither do microorganisms. And so if you have different crop residues, different organisms are favored for decomposition of those residues. And so you're building that biodiversity in your soil. I touched on the benefits you get from cover crops, so I'm going to kind of move forward there. But manure is another great way that we can build organic matter and manage our soil health. Manure has microbes in it. You know, it's organic material that, as we apply it, it contains microorganisms, and when it gets in the soil, it also is good food for the microorganisms that are there. It provides soil organic matter. It recycles nutrients from our animal systems back into the soil. There's evidence that manures can suppress diseases. And you know, and you do have to plan a little bit with manure. The rule of thumb is the manure that you put on this year, 50% of that, if you're putting it on for nitrogen, or maybe you're putting it on for phosphorus, whatever nutrient you're putting it on for, about 50% of that is anticipated to be available that growing season. And then the following season, 50% of the 50% that was left from the previous season is available, and so on. It kind of breaks down over time. You know, here in Lexington, there's lots of local manure around. A lot of it's horse manure. You might have your own animals, so it might be on your farm or maybe your neighbor's farm. So, you know, there are options out there to get manure into your systems. Compost, you know, compost is basically, as I described earlier, it's humus. It's stabilized organic matter, and it does all those good things like promote air movement, water holding capacity, nutrient holding. It's beneficial microbes. There's also evidence that compost can suppress diseases. And this is recycling of materials that you need to process on your farm, or plant residues. They could take up a lot of space, or you might have to transport them somewhere. And so compost is a good way to recycle those nutrients and get them back out on the field. Increasingly, you might hear people talking about regenerative agriculture. This is sort of what was old is now new again. Used to be that the traditional farms, lots of them had animals integrated into the farm. And it's, it's a great way of diversifying what you're producing on the farm. All your eggs aren't in one basket in terms of, whether your crops are successful or not. Maybe, if you have a bad crop year, you have animals on the farm that might provide another source of income. But more and more people are looking at animals and the way that carefully managed animals on a landscape in terms of grazing management can help increase soil organic matter and soil health in a system. And so the picture here is some research that we have going on at Kentucky State, where we've got a 5-year crop rotation that has organic corn, organic soybean, and then 3 years of goats on pasture, and go back into corn, soybean. And I'll show you a little bit of data from that here in a minute. But, these are also, much like crop rotation, it does a lot of these good things. It breaks weed and pest cycles. It breaks disease cycles. The animals help clean the fields. And in terms of cleaning it, I'm talking about in terms of pests, in terms of weed seeds. And so, there's a lot of good things that can be derived from integrating animals into a carefully managed rotation. All this stuff takes planning. You got to think about timing. You got to think about your soil conditions, especially if you're talking about going out tilling or running any other kind of heavy implement on your field. Less aggressive implements. If you got to till, which I'm in organic, a lot of them, I had in the organic space, a lot of time we still use a lot of tillage for weed control. And so I like to go things that are less aggressive. Rather than a mold board, maybe I'm out there with a disc harrow. And I like to minimize that if I can. So everything, needs to be thought out. Moderation, in terms of incorporating some of these practices, start small. too much too fast can lead to problems if it's something that's new to you. You got to think about too much manure can lead to nutrient runoff and leaching. Maybe you've got, timing of manure application can lead to bacterial pollution if your manure is running off your landscape into a creek or something like that. And so all of this takes a little bit of consideration. And if we have time, Dakota, do we have just a little more time? I know we're at 7:30. If everybody's
Yeah, we
willing.
can go on a little longer since
Yeah, I just got a
took us
couple
minute
slides
to
I'll
get
go
it
through
pulled
real
up.
quick.
Yeah.
This is our integrated rotation experiment at Kentucky State, and you could see, we've got, again, it's a 5-year rotation. We've got corn, soybean, and then pasture year 1, pasture year 2, and pasture year 3, and we're integrating goats on that pasture. And the idea is, these are organically managed, and as I touched on, we're doing tillage because that's our weed control. And anytime you do tillage, you're breaking down organic matter. So we have 2 pretty intensive cropping years, and then we follow that up with 3 years of goats on pasture. And what we're hoping to find out from this experiment is, well, does this practice of putting goats on pasture rebuild the soil organic matter losses that we incur during those cropping phases? So these are goats hanging out in a couple of our research paddocks. On the right is a pasture plot that the goats are actively grazing, and then on the left is the plot they're headed to next. We put that hay wagon out there for shelter. They hang out under it on sunny days, and also if you've had goats, they like to climb, and so some days you'll walk out there and the goats will be standing up there on the trailer, or on the hay wagon rather, looking down at you. And so this is a picture after the goats have come out. The plot on the left, the goats have recently grazed. The plot on the right has not been grazed, and so you could see the difference. We try to manage these with sort of this take 50, leave 50 philosophy, where after they've grazed about 50% of the forage in the plot, we move them to a different pasture plot. We don't want to overgraze. We just want enough grazing done to stimulate root growth, stimulate additional growth above ground. And so it's all we try to be careful about how we manage it. If you look real close, the picture on the left is a plot that has not been grazed yet. On the right is the ground in a recently grazed plot, and you can see the goats left some little nutrient nuggets behind. And so, that's manure that's going to turn into organic matter for us. And we're not disturbing these plots for 3 years. So yes, we're adding goats and they're doing their goat thing, peeing and pooping on the landscape, but we're also not disturbing these plots for 3 years as it is in pasture. And so all of that together does help, and that's what we're seeing here. This is data, and you guys have bared with me for about a half hour, about an hour now, and so looking at data at the very end is always dangerous. I don't want to lose anybody's attention span, but if we look at this figure, and I don't know if you can all see my cursor, but if you look at the bar that is CNP, that's actually a plot where we grow corn and soybean every year with no pasture. And then I'll call your attention to the far right, where we have PP, and that is perennial pasture. And so those are kind of our control plots. So on the one extreme, we've got heavy cropping every year. We would expect some organic matter to be depleted there. And on the other side, we have pasture every year, and we would expect that since it's never disturbed, we'd probably build a lot of organic matter there. And then in between, you see the different phases of this 5-year crop cycle. So C1 is corn, CS2 is soybean, P1, P2, and P3 are those 3 years of goats on pasture. And what you're looking at here is labile carbon. We measured it with potassium permanganate. And again, this is that carbon that the microorganisms, it's available to the microorganisms. It's a pretty good indicator of soil health, soil quality. And it's also a good indicator of, change over a shorter term in organic matter content compared to say your total organic matter test that you get from your soil testing lab. And so what we are seeing is, when we are growing those corn and soybean phases of this rotation, we're depleting our soil organic matter. But as we move through that pasture sequence over 3 years, we are almost approaching organic matter levels comparable. In fact, there's no statistically significant difference between P3 and PP. So statistically, these are the same. The pasture year 3 does have a little bit less in this particular figure, but basically we're approaching those organic matter levels that we would see in an undisturbed pasture, and so pretty good. And what it tells us is that yes, we know we're beating the soil up in that cropping phase, but we're regenerating that soil through those pasture phases with goats. This is a similar figure, but instead of carbon, I'm showing you water stable aggregates. So soil aggregates are a measure of soil structure. So you could see kind of the same trend that we saw before, where, in those cropping phases that you see here on the left side of this figure, CNP, CS1, CS2, we're beating up our soil pretty good. We're tilling it, and we're doing some damage to the soil structure. But as we move through 3 years of pasture, it's not getting quite back up to where it was with the perennial pasture plots, but it's improving over time. All right, so we're almost done. What do we need for keeping a soil healthy? We need more people to think about, soil health, more people to think about soil organic matter management. I think it's, like I said, I'm super pleased that Dakota and Cindy invited me to be part of this series. I really enjoy working with people on soil health, and we need more people to be talking about soil health, more people in my line of work, extension. And so I think we'll see more of that going forward, especially, given that carbon dioxide in the atmosphere is related to carbon in the soil. They're inherently linked. And so as people start thinking about how do we keep carbon out of the atmosphere and keep it in the soil, we'll hear more people talking about soil health. What we need is people to figure out, and I don't know how many people are interested in it in this session, but there are people that are interested in the carbon markets, right? How can I get paid as a producer for all the good management practices that I'm doing and keeping carbon in my soil and preventing carbon from getting in the atmosphere? Those conversations are going on right now. People are figuring out what these carbon markets are going to look like. And going forward, there are going to be people figuring out, how can farmers benefit from the good management practices they do in terms of management incentives. But before we can get too far on that road, we really need to figure out what is the value of the carbon in the soil. And a colleague of mine up at Ohio State, Rafiq Islam, he said that 1% organic matter. Jim Horman was also involved in this study, I should point out, but they said that 1% organic matter was worth 680 in savings per acre in terms of your nutrients. So, if all of this other stuff is esoteric, maybe financial reasons mean something, right? And so everybody's trying to cut costs and meet margins. What is the value of a percentage of organic matter? This was up in Ohio. It may differ from region to region, right? Every region's a little different. You can walk across my fields at Kentucky State and walk across 3 different soil types. So those numbers might not be the same in every single soil type, but we need to start figuring out what a rough value, monetary value of carbon in the soil is. We need to figure out better testing methods, more straightforward testing methods. We again need to incentivize these practices that will build organic matter, build soil health, get a clear picture of carbon markets, and then get a clearer picture of what compensation for producers. Look, I was at a conference a couple of weeks ago in Ohio, and this is coming. Sat through an entire session at this conference where they were talking about the value of carbon in the ecosystem. There were about 50 farmers in the room that wanted to learn about how they could take advantage of keeping carbon in the soil and the management practices that they're doing, so that, they could turn that into a financial win. If you're interested in more on soil health, NRCS is always a good resource. I dropped a link in this presentation. They've got basic info, management tips on their webpage, assessment info, and some additional reading ideas. There is also the NRCS soil health. I'll just look at this, and the link here is not going to work because that's a link to my desktop and the computer, the file on my desktop. I don't know how it came in like that. But on the USDA NRCS website, they do have a soil health test bucket checklist. And so you can go out and devise your own soil health test kit. It works pretty good out in the field setting. It touches on a lot of those things that farmers already know, right? It's just ways to sort of assess those things. I am extension. Part of my job is outreach. And so if you have questions on soil health, I'm happy to get in touch with you and work with you on whatever you may need answers on. So feel free to contact me. My contact information is here on the slide. And I'd be happy to work with you on soil health. I don't know if we have time for questions, but I'll make time if y'all want to hit me with a couple.
Yeah, if anybody has any questions, drop them in the chat real quick. While y'all are doing that, we want to thank Shawn for presenting with us today. It was a great presentation. Once we figured out the technical issues.
Yeah, I'm sorry about that.
We will get this. This is recorded, and so we will get this put up on the Kentucky Horticulture Council YouTube page. And I'll also send a link to everybody that registered to go back and review this. Anybody has any questions?
Let me see. I see one about high tunnels, and I'm sort of the guy at Kentucky State with high tunnels. Probably a dead end question here. As I have more information, but recently received a soil test with high salt levels and low pH. Fertigation system in the high tunnel, supposedly the same products are used in field production, but the pH in the field is normal. So what you're getting there is you're growing under plastic, right? And so that irrigation is probably the only water that you're bringing into that high tunnel. And I don't know what your water source is, but we see this a lot in high tunnels, where if you are on city water or irrigating from a pond, even though we call it fresh water, it has salt in it. And so over time, that salt is going to build up. I saw this myself at Kentucky State 2 years ago. We were in our high tunnels and we had a salt crust forming on a couple of our raised beds. It is no longer a problem because we replaced the plastic on our high tunnels, and the plastic was about 8 years old. We let it sort of rest for a season with the plastic off and all the rain. Fortunately, here in Kentucky, the solution to this is, when you take your plastic off to replace it, and I don't know if your tunnels are ready for that or not. It may not be what you want to hear, but flushing it with fresh water is an option, whether it's rain or whether it's getting fresh water in there in some other way. Is how you can get rid of those salts. And the pH is it's related to the fertigation, I suspect. Anytime you're bringing in nutrients like that, it's particularly in a concentrated setting, those nutrients do tend to reduce the pH of a soil, and that you may have to go and bite the bullet and bring in some lime on it. pH 4.7 is pretty low. But yeah, I would think about getting some lime on there. We usually shoot for about 6.2, 6.3, and that's where you get your optimal nutrient availability.
I've also got one. Do you have any favorite cover crops to plant this time of year?
Well, we're going spring into summer right now. So this time of year, I'm thinking about things like sun hemp. And obviously I'm assuming these are in plots that you don't want to, these are plots that you may, or fields that you may have grown something in previous years, and you're just doing a soil building year. And so, things like buckwheat, you can get a lot of biomass in buckwheat really fast. It takes about a month and a half to 2 months to grow a good stand of buckwheat and then terminate it before it goes to seed. And great cover crop for building organic matter in the summer. I also like sun hemp, which is a legume, so you're getting a little bit of nitrogen with your biomass. We've been playing around with a couple of different mixtures at Kentucky State, and so last year we had a mixture that had some Japanese soybeans, sun hemp, Sudex, which is sorghum grass, Sudan grass, which is also another nice summer cover crop, by the way, Sudex. Lots of biomass, and that actually has some allelopathic properties. So when you terminate the cover crop, you don't want to plant right into it because it can inhibit germination, but that inhibition of germination of other plants can be beneficial if you time it right, and you want to suppress weeds. So yeah, those are some of my favorite summer cover crops. Fields are around 6.4. Yeah. So Story, it sounds like you need to think about ways to get fresh water into your high tunnels and some lime in there.
Any more questions? I think I see any in the chat. Here's one. Do you do much with Bokasa composting? Bokashi?
I've heard the term, but I will I haven't done a lot with bokashi. I haven't done anything with bokashi. I don't want to sound more knowledgeable than I am. I've heard the term. That's about it. I guess it's about some kind of layering of compost, but I haven't done a whole lot with it. No. Sorry, I can't contribute more there.
Well, I don't see any more questions, so we'll go ahead and end this. Thank you all for coming, and thank you again, Shawn, for presenting. We will get this sent out to everybody.
Appreciate it. Y'all have a great evening. If you do need to get in touch, feel free to reach out via the contact info I shared earlier. And there it is again.